Hello and welcome to the ABC Networking channel. My name is Dick van Oeveren. In the previous video of this series I showed you the GUI of a Flask app that monitors Aruba networking switches, and I promised you to tell you more about how the app actually works. If you want to see the app in action, just check out the previous video that I made and you should be good to go. First I'm going to show you the actual architecture of the app, which will really help you understand when we dive deeper into the script. So on this page you see how the main framework of this app is built. What we have is an init file where all the page routing takes place, and there are two pages on the app. One is to show the devices, which is the default page, and here's where you can add, edit and delete the devices and get some global information. The second page is the one that we will be focusing on. That's the device info page, and this is where all the dynamic stuff takes place. This page shows you the device and interface information, as well as some line charts with CPU and memory utilization. What happens on the device info page, you have to select one of the devices from the pull down list, and these are the devices that are created on the main page. And once that device is selected, the app will determine whether it is an arubaos-cx switch or an arubaos-switch device. So the way that this app is built, it also allows you to add other devices that support REST APIs. Once the device is selected, the page will obtain information that is stored in a database and then dynamically update the page every 5 seconds. Now let me show you the next slide and explain how the dynamic updates take place. And before I do that, let me just explain to you what the colors mean. You can see that all the objects in the diagram have different colors, and they refer to the source location of the action or the code. So on top you'll see select switch, which is in green, and these functions or definitions or routes or whatever code you have are located in the init.py. You see some blue icons here as well, some blue objects here as well. These are located in the classes, so you can find the code of these functions in the library, the classes library. And then you also have the yellow icons, the yellow boxes, and these are the HTML pages that are rendered from the init.py. So you will find the reference of these HTML files in the init.py. And let's start from the top. Based on the selected switch here, whether it's arubaos-cx or arubaos-switch, the app will either render the device info CX page or the device info switch HTML page. So these pages are called from the init.py. So the HTML page contains an HTML div, and this HTML div calls another route in the init script, which is update device. So this update device route in the init script calls a definition in the classes Python script. And this definition contains all the necessary REST calls that are needed to obtain information from the device, regardless of the device type. Once that information is obtained, it is stored in the database. So the update device definition performs all the REST calls, so pulls all the relevant information from the switches and then stores that information into a database. So if the device is unreachable for any reason, the information that is stored in the database is obviously retained, so you always have the latest available information once you select this page. Now if we drill a little bit more down into the process, if your selected device is an arubaos-switch device, an additional check takes place. This is because the arubaos-switch device can operate in different configurations, either as a standalone switch in a VSF stack or using backplane stacking as in dedicated stacking cables. Now based on the switch configuration, we can show different additional information. For example, a VSF switch obviously has some configuration items that a backplane stacking switch does not have. Once the switch identity is known, we can start showing the information that is stored in the database by the update device definition. And what happens is that also this information is being refreshed every 5 seconds. So you get the device update device info definition called every 5 seconds, which updates the database. And when showing the information, the page is also refreshed every 5 seconds. So you always get the latest information that is available. Now the refresh is achieved by a function that is available with jQuery, and I will show you later on in this video how this works. But it's basically a div tag that is defined on the HTML page. So this div tag is populated by information that comes from a JavaScript, and this JavaScript calls the definition that is defined in the classes.py and obtains the relevant information from the database. So, and this is really how the engine works. It looks a bit complex, but really in the way the structure is built, this allows you to extend the app to support other REST capable devices. Now let me dive into the scripts. When we start with the init script, and this is the actual core of the app. And let me start from the top here. So what you can see here is I am in this part I am importing all the relevant libraries. So Flask, Flask Bootstrap, JSON. I'm using some date time conversion here. And I am importing the classes py as well. So this is the classes.py that I've written with this app. So this is the instantiation of the app, and what I'm also doing here. So typically, what you have is when you are calling a Jinja template. So if you're calling an HTML file with Jinja scripting, you typically cannot make any calls to any Python definitions. Now with these commands allow you to call a definition from a Jinja file. So this comes in really handy. Okay, so drilling down a little bit more. So here's your default page. So that's your standard page. Really very straightforward. What we're doing here is we are calling a definition in the classes library, which contains all the database actions. So it contains the selects, updates, insert, deletes, and everything. And then based on that form result, I can render a page called index.html, and I'm feeding that index.html with the form result. So with the result from the database. Now let me just drill a little bit down, because here is where it really gets interesting. So this is my route where the device info page is called. So this would be your main device info page. So what I'm doing here is if there is a form result, so if I have selected a switch basically, I can do a query string and obtain information from the database of that switch, and then I can assign all types of values to different variables. So if I have for example in this case, if I have an interface field in the form result, so if my interface field is filled with data, that interface variable is filled and then can later be used in the page rendering. Okay. Now here is the part where I get the actual rendering. So if my OS type, which I have obtained from the database here, so if my OS type is either arubaos-cx or arubaos-switch, I need to render different files here. So if it's CX, I'm doing the device info-cx.html. If it's arubaos-switch, I'm rendering device info-switch.html. If there is nothing to render, so if there's no selection made or if that OS type is empty, I'm just rendering the device info.html, which is the default HTML. And drilling a little bit further down, I have the show interface, show device, and show graph, and update device info. So these are all the other routes that are created in order to, obtain. So for example, the update device info here, the route, that app route, the update device info here, really calls the function or the definition. Actually, it's called definition in Python. So based on the OS type here, so if my request information OS type equals arubaos-cx, I need to obtain. I'm calling this definition that obtains all the information from an arubaos-cx switch. If my operating system is an arubaos-switch, I am calling a different definition here that obtains the information. And I'm also getting, so from this request arg get, I'm also getting the stack type information. So so you have to hang on a little bit about this request arg thing. So this is really the information that I am pushing from the JavaScript that is called. So a little bit later on in this video, I'll show you where this information comes from. So and then you have the show interface, show device, and show graph route. Let me take the show interface first. Again, you can see the request arg get here. Again, this is also information that comes from the jQuery JavaScript function. And then again, based on the operating system, I am rendering a different HTML file. So if my OS type is arubaos-cx, I'm rendering the CX interface. If it's an arubaos-switch, I just do a normal show interface. For the show device, that's a little bit, so there's a little bit more of a check here. Again, it's very similar. So if my operating system equals arubaos-cx, I am obtaining here, I'm obtaining all the relevant information from the database, and I am pushing that information in this show CX device HTML. You can see that here. Get all this information that is pushed into that HTML file. That one. Okay. If my OS type equals arubaos-cx, arubaos-switch, then what I have to do is I have to check whether the device is stackable or a standalone switch. So the JSON structure, as the remark is saying, the JSON structure is different. So we need to render different scripts based on the device configuration. Right. So you're getting the device info, and so that device info contains the sysinfo, VSF, and BPS info. Now, if my if this jQuery function pushes the standalone, so if my switch is a standalone switch, I am rendering a different HTML. So I'm rendering the SA HTML. If it's a VSF switch, I'm rendering the show device VSF. If it's a backplane stacking device, I'm doing a show device BPS. And again, providing all the relevant information to be shown on that page. And that's, I mean, that's really how it works. Again, with the show graph, it's really very much the same. So with line charts, I'm actually obtaining the device ID here. So I'm calling the line chart definition here, providing all this relevant information. Again, I will show you this in the classes.py how this works. So this is really calling the definition and returning information in a dictionary that is ready to be rendered in a line chart. And that's actually something that I forgot to mention, is that for the graphics and for the line charts, I'm using a very cool library called PyGal. You won't see the PyGal library in this file because it is stored in the classes file, but the PyGal library is a very easy to use library that allows you to show line charts, bar charts, donuts, whatever you want to show. It's really a very cool library. So having said that, let me just move to the classes.py and let me explain to you what's all in there. Right, so in the classes we are also importing a lot of stuff here, importing a lot of libraries, requests, JSON, URLlib3. I'm doing some encryption and decryption here, so I am importing the Cipher library. It's really cool, really cool library. And the other thing I just mentioned, here's my PyGal library that I'm importing here. What you can do with PyGal is you can also use some custom styles here. So this is just an example of a style that you could use, but just look at the documentation. PyGal is very well documented from that perspective, and there's a lot of cool stuff that you can do with PyGal. Now let's have a look at the definitions. So it's all definitions. I'm kind of not using classes. I'm really fond of definitions. I don't know why it is, but I think it has all to do with simplicity and control. But anyway, so my definitions. So for some functions, I need to convert my timestamp here. That's what I'm doing here. I have some definitions that are being used for logging in, logging out of switches, and obtaining information from switches. So this is actually that I already covered in one of the previous videos. So logging into a CX device, logging out of a CX device, logging into a switch. So that's an aruba-os-switch device, logging out of that aruba-os-switch device. So the other definition here is performing an SQL query. Okay, so that's what you could do. So I'm using this SQL query for all different types of definitions. There's two definitions here that allow you to encrypt and decrypt passwords. I don't really want to store passwords in a database that are in clear text. So what you can do is you can use a salt and password and encrypt that and decrypt the relevant information, like for example switch passwords. So two definitions here. I've got the definition for get-rest-cx. So this is really to obtain information from arubaos-cx devices, and also one for obtaining information from Aruba-OS switches. Again, I've covered these two definitions in a previous video, so if you want to get some more information on that one, just refer to those other videos. Checking, this is a definition that checks whether the device is online. So I'm using this definition in the update device definition, because if the device is not online, it doesn't really make sense to obtain information from the device. So I'm first checking if the device is online. If the device is online, then I can do all my REST calls. Okay. So this is the okay. So this is the definition that I am using to obtain all the relevant information. You can see that's quite a large definition. But it's so this definition I'm using to obtain all the information from an aruba-os-cx switch. Now let me just go through that function. First, I am setting some variables here, so empty variables, and then the next command is logging into the switch. And then next what I have is I have a list that contains all the URLs that I want to use to obtain the information from the aruba-os-cx device. You can see it's quite a large list. So it's like, I don't know, 10 or 11 calls that I'm making. So if you want to obtain more information from that switch, from that aruba-os-cx switch, you can just add more URLs to that. So, and then in the next part, really I'm looping through that URL list, and then every time in that loop I am obtaining the information that is based on that API call. Okay, I'm doing a try except because if I have a failure here, if I wouldn't do the try, then my Python script stops, and I don't really want that. So so if I do a try and my command fails, I'll just do a pass, and then it's just going to the next API call. Okay. Now there are some calls that I'm making that really return some information that the database doesn't like in terms of formatting. So what I need to do is I need to make some changes to, like in this situation, the separator. So so this is just a small adaptation of the result I'm getting back from the switch. So nothing to worry about. That's something that you have to do with a trial and error and see how it fits and how I can then insert the information into the database. Okay, so that's the same here. So I need to kind of adapt or change the result. Okay. The other thing is that if I am calling the CPU or memory values, I really want to store them in an array. Okay, so so I'm getting that information from the switch, and so what happens here is that I am adding the CPU values and the memory values into the into an array, into like a list, and that list contains all the previous values here. So here you can see I'm obtaining the CPU and memory values here, and I am appending those values to the list. And what you see here is that I am using the last 30 values. So if I would have 30 values already in my database, and if I add a new value, so the oldest value will be removed from that list. Okay. So And then what I'm doing here is the so the VRF info here. So if my sysinfo is larger than 2, so I'm just checking whether I have sysinfo, bridge info, and VRF info. If that is the case, I can update my device database, so my device entry in the database, and send an SQL query. And then after that, I'm logging out of the arubaos-cx switch. Okay, and to just go back up, where is it? So that's the SQL query that I'm doing here. So, and that's the CX info. Now with the get switch info, it works very, very similar. You can see it's also a pretty big definition. Um, so what we have with the arubaos switch, obviously, is that I have 3 different options for the arubaos switch. So it can be a standalone switch, can be a VSF switch, or it could use backplane stacking. So I mean, so that means that my definition becomes a bit bigger. Okay, so for this definition, getting switch info, I'm logging into the switch first, and you've got the URL list here with all the URLs, which is like similar as to what we did with the get CX definition. So list of all the URLs that we're calling, and I'm doing a for next loop here. So what I'm doing in this for next loop, again, I'm doing a try result, getting a result. So get rest switch here. So I'm getting the information. And what I'm doing here is I am joining the sysinfo with the result. So initially sysinfo is empty. So that's an empty dictionary. And what I'm doing is every time I'm going through a loop, through this loop, I am adding the result to the sysinfo dictionary. So what I'm doing here is I am checking whether the URL that is called, so I'm doing the for next loop here for sysitems. So if my sysitems is system status switch, in the result of that URL, so that REST call, I can see what type of switch I'm using, whether it's a stacked switch or whether it's a standalone switch. Now, if it is a stack switch, the switch type information that's returned from sysinfo is st_stacked. So if that is the case, I know that this is a stacked switch. And then what I can do is I can call some different URLs and get some different information here, right? So if that URL doesn't exist, for example, when I'm using, so when I'm using BPS stacking, there would not be any information here, or if there's an error, I'm doing a pass. But getting the information. If I don't see a message in the VSF info, message means that there is some kind of error in obtaining the data. So if I don't have this in my VSF info, I can join, I can merge the VSF info into the sysinfo. So that's for VSF. Same for BPS. So if if my switch is a stacked switch, I'm trying to obtain the BPS information here. Same, if not message in BPS info, I can join the BPS information into the sysinfo. And then as a follow-up, I can obtain some additional information. So I can obtain interface statistics, like port statistics and PoE statistics. That's what I'm doing here. I can do that for standalone or VSF or BPS switches, doesn't really matter. Okay. And again, I am merging that information here into the interfaces. So the interfaces dictionary would contain port statistics and PoE information. A little bit further down, I can also obtain LLDP information. So the LLDP information is also stored in like a different column in the database. So it's pretty straightforward there. And in this part, if my stack type is VSF, I can obtain additional VSF information from the stack based on this URL list again. So we've got this list of URLs that I can call, and I can kind of like obtain all the VSF configuration from the stack, and then I can show it on the page. Again, you see here VSF info, that's the dictionary, and I'm joining the result into that VSF info dictionary. So, and CPU and memory, I can get CPU and memory information from the commander actually. So if you have a VSF member, the commander switch obtains or contains actually the CPU and the memory, CPU utilization and memory that is available. Again, I can get that information and I can merge that. Also very similar as to what I'm doing with the arubaos-cx device. And so that's for VSF. And then if my stack type is backplane stacking, again, I'm doing very similar things here. Getting the BPS info here, doing the CPU and memory information here, appending the values. So you see, it's all very much the same. And once all that information is gathered, and if my sysinfo is true, so if my sysinfo contains values, I can do the query and I can update the device in the database with that relevant device information. Okay, so discover model. So that's a definition that I already like kind of covered in one of the previous videos. So my device DB action. So here's where all the database actions take place. Actually, this is really very much for the main page, for the default page, not for the device info page, but you know. Some interface DB action definition. So this is the definition that obtains all the relevant information from the database for showing it on the HTML pages. So really this is called from the interfaces page. It's really very much obtaining information from the database and then assigning it to a variable and then returning that information back to the calling function. So interface DB action, really this definition is called from the show interface here. So there you go, interface DB action here. So the definition is called from the init file. Okay. And I've got the show line chart here, which is really the definition that obtains the relevant CPU and memory information, puts that into a data set, and then adds it to the line chart, and then returns that line chart information. So really what I'm doing here is I'm assigning the variable data set, obtaining the information from the database of that switch. Based on the OS type, I need to set a different y-axis title. So for arubaos-cx, I'm using memory usage, and for the aruba-os-switch it's the available memory that I'm showing. Again, so the other thing here, oh yeah, so this is important. So if my OS type is aruba-os-switch, the memory and CPU utilization is only available when you run the switch in VSF or BPS. For standalone switches, there is no REST call available at the moment that shows you the memory memory and CPU utilization. Okay, so setting the X labels and values, and then so what I'm doing here is I am appending the values from the data set. So you do 4 items in data set, so that's the data set that comes from the SQL call. I'm appending those values here. And then it's basically creating the PyGal line chart object and returning that line chart object back to the init.py. So that the init.py, drill a little bit down, you see the line chart object here, and I am rendering that response here for that line chart. And that's really the classes.py. Now let me show you some of the HTML files. And here's where you can really start seeing what's happening. I'm showing you the device info switch.html. I also have the device info CX here. It's really there is not a lot of difference between the two HTML files and the way it is built. So these pages are the main pages that are built on the, like in your web browser, and they are basically contain like 3 divs, and these 3 divs are different HTML files. So for device info switch .html is the same. It works in the same way as the device info cx.html. Okay, so I was in the beginning I was referring to pages that refresh. Now the way to achieve this is through a jQuery function that we have, and that jQuery function is called in a JavaScript. So what I'm doing on this page is I am loading these JavaScripts here. Okay, so this is the part where, and then these are the JavaScripts. So it's device info, line chart, update device info.js, and interface info.js. So these are JavaScripts. Now let me show you the device info.js, what actually happens in this script. So when this script is called, what I'm doing is following. So this is the script. It's a refresh function. So this is a jQuery function where I am assigning some values to variables. So I'm assigning the device ID, the OS type, and the stack type, and that is information that comes from the HTML page, so from the device info switch. Okay, and then what I do is I am filling the div with this identifier, also located in this HTML file. I'm filling that div with this HTML, and I am pushing this information. So I'm pushing the device ID, the OS type, and the stack type. Okay, and I'm doing a refresh and set it in interval of 5,000. Now we'll just quickly go back to this one. So you can see here I'm loading show device. Now if I go to my init, you can see that I have an app-root show device, and that app-root is obtaining information from that JavaScript, and that's my request arguments get. I'm, I'm assigning values here in the URL. So these are basically get values. So that these are values that I have to obtain through a get, and now I am obtaining that information through the request args get command. So there is where you get your information from. So really this route gets information from this JavaScript here. And then obviously once that's done, I can start render my templates here. So show CX device. Well, in this case it's not CX, but it is an aruba-os-switch. So it's either one of these three HTML files that I'm rendering. Okay. So if I go back to the device info switch, now let me just show you, and let me just do a search device info, how I call this script. So I'm calling it here. So if I have, if my form result device ID exists, so if I have selected a device ID, I can really show that information. So what I have here is a container here, and in that container is a row. So this is all bootstrap stuff here. All these divs are bootstraps. And what I have here, so this is the relevant line here. So that's my div data chart equals device info, and that is this thing here. And so this JavaScript is assigned to this div. So that means that this div will get refreshed every 5 seconds with that HTML file. I don't know, depending on what device you have. So it's either BPS, VSF, or standalone. And that's really how it works. If you go a little bit to the top here, you see another div. So div data update info, update device info. Now this div is used, let me just show that, for the update device info.js. So that's this thing here. And so this JavaScript, I mean, it works exactly the same way as your device info, your line chart, your interface info. What it does is it loads the update device info page. Now if I go to the init.py and go to the update device info route here, here is where this call ends up. And what this call does is, based on the OS type here, whether it's CX or switch, it obtains the relevant information from the switch, and as explained in the classes, so that's obtaining all the information and storing the information in a database. So that's really the heart of your application. And then what you do basically is you let me just go back to the init. So for example, I'm rendering this page. So if I do a show device VSF, for example, then you can start. Then you can start rendering your page with all the information that you get from from the back from the system, right? So you get all this sysinfo, VSF info, BPS info, device info, and then you can show that information in just plain HTML. You can see some Jinja here as well, really straightforward Jinja for next items. Really these lines really check whether value exists, or what the commander is, so who the commander is. If a switch is a commander, then I have to show some additional information from that device. So really, I mean, this is really very straightforward stuff here. So you just go through that at your leisure and see how this all works. And that's really how the app works. And this concludes yet another video on Flask with Python. I hope you liked this video. If you do, please hit the like button. If you have any feedback or suggestions, please let us know. And as always, thanks for watching and bye bye.